All right, guys, this is Mrs. Lyons, and this video is going to teach us something about something called mole ratios. Okay, and by the time we leave here today, you should be able to look at a chemical equation and figure out how many moles either are needed or can be produced. Okay. And then we're also going to talk about this chemical equation, some different ways that we might read what it means. Okay, so first of all, if you've noticed, the title of this unit is stoichiometry, which is a really big word and kind of scary, but it's really not so bad. All right, so stoichiometry comes from the Greek stoichen, Stoichen, which means element. And metron, or metron, I'm not sure how it would be pronounced in Greek, means measure. So in other words, what stoichiometry is the measurement of elements, okay? And not just elements, but compounds and molecules and things like that, okay? And like I said, we need to be able to do this when we go back into the lab and do the measure things, all right? So stoichen means to measure elements. The official definition of stoichiometry, all right, is the study of quantities, okay, the study of quantities as it relates to chemical reactions. Okay, so the study of quantities as it relates to chemical reactions. Okay, that's the official definition. All right, so we've been looking at balanced chemical equations for a while now. Okay, the last unit we focused a whole lot on balancing these things. Okay, well, there's three ways that we could read or talk about what's happening in a chemical equation. All right, the first way is in terms of molecules. And we drew these pictures in the last unit where we drew the element symbols and we didn't necessarily make them in molecules, but we counted them this way when we were balancing. Okay, so if you were looking at this might say that we have one molecule of N2 combined with 3 H2 molecules, and that produces 2 NH3 molecules. Okay, so that's kind of what we've talked about in the past. You can also talk about, you can use this chemical equation in terms of grams to kind of show you that the mass, the law of conservation of matter, so basically whatever amount of matter we put in is going to be how much we get out. So for example, if I say that I have 28.02 grams of of nitrogen, and I have 6.06 grams of hydrogen, I would then produce 34.08 grams of my product. Okay, and if you look, if you add these two numbers together, okay, what you're going to get is 34.08. Okay, so basically that's saying what you put in is what you get out. Okay, so what this is showing us, is that the mass of the reactants and products are always equal. equal. I didn't leave myself enough room. All right. And that's what the law of conservation of mass says, is matter cannot be created or destroyed. It can just be rearranged. All right. Finally, and this is the way that what we are going to use. All right. We can use this, and we can say that this is showing us in terms of moles. Okay. So basically, I look at this equation and I say that I have 1 mole of N2, and I'm combining that with 3 moles of H2. And what I'm going to produce is 2 moles of NH3. Okay, so we can look at this and we can start to apply it to our balanced chemical equations and to measurements in the lab. All right, so we're going to talk about something that we call a mole ratio. All right, so the coefficients in the balanced equation represent the smallest whole number mole ratio between the reactants and the products. Okay, and we know what a ratio is, right? A ratio is, for example, if we were to count, if we were going to count people with red hair and people with black hair, and we wanted a ratio, you would have the number of people with red hair to the number of people with black hair. Okay, so what we can do with this, all right, is we can decide what the ratio is of elements to compounds. And what we're going to use are the coefficients in our balanced chemical equation. Okay, so what this tells us, okay, this tells us for every 1 mole of nitrogen, okay, we could make 2 moles of NH3. Okay, just by using the coefficients in our balanced chemical equation. All right, we could also say, another example, if we have 3 moles of hydrogen, we would need to use 1 mole of N2. All right, so for every 3 moles of hydrogen we react, we would need 1 mole of nitrogen. Or we could say, for every 2 moles of NH3 we produce, all right, we would need 3 moles of hydrogen to start with. Okay, so basically you can do a ratio of any of the products to any of the reactants using the coefficients of the balanced chemical reaction. All right, turns out we can also do some calculations. We're going to kind of build off of what we did yesterday. First thing we're going to do is we are going to balance this equation. Okay, and notice I've got something in here that I showed some of you in the last unit. When we have water in our equation and we have hydroxide OHs and H's on the other side, we can break water down into HOH. So let me show you how that works. I'm going to tally. I'm going to balance this equation first. Okay, so I've got potassium, I've got hydroxide, which is OH, and I have H. Now, what I want you to see, okay, is that when I count OHs, I'm going to count them, and now I'm going to compare those 2 numbers. All right, and when I count H's, get a different color marker. When I count H's, I'm going to count these. Okay, I'm going to compare these. So let's count how many of each thing we have on each side of our chemical equation. All right, So over here we have 1 potassium, we have 1 OH, and we have 1 H, okay? Over on this side, we have 1 potassium, 1 OH, and 2 H's. All right, so to balance this, I'm going to put a 2 here, which now that gives me 2 of the single H's. It also gives me 2 of the OH's. So let's see. So hydrogen's okay. I need to put a 2 here to give me 2 OH's, but that now gives me 2 potassium. I'm almost there. If I put a 2 here, finally everything is all balanced. Okay, so my coefficients are 2, 2, 2, 1. All right, so here's what we are going to do. If you read this problem, if 3.86 moles of potassium reacts completely with water, how many moles of hydrogen would be produced? Okay, so we're going to spell out our known and our unknown. Okay, so our known is 3.86 moles of potassium. Okay, our unknown is, let's see, how many moles of hydrogen? So we want to know moles of hydrogen, okay? And that's H2. Now, what I would do is I would look at your mole ratio first, okay? So we're looking for the mole ratio of potassium to hydrogen. So in other words, if you look at your coefficients, that would be for every 2 moles of potassium, we would produce 1 mole. I'm going to do this. This is a little way you do ratios. So for every 2 moles of potassium, I would produce 1 mole of H2. So now we're going to set this up into a problem like we did the other day when we were converting from grams and moles. So our given is 3.86 moles of potassium. Still always going to put that over 1, okay? And this is where our down and diagonal, all right? Here we have moles of potassium. So that's going to go down and diagonal. So on the bottom, I'm going to have moles of potassium. On the top, I'm looking for moles of hydrogen, so moles of H2. Now, when you have moles over moles, okay, that should give you a sign that you're talking about the mole ratio. So what you're going to do, it would be 1 mole of H2 and 2 moles of potassium. All right, so if we do the math, we're going to take 3.86 times 1 over 1 times 2. So let's see if I plug this into my calculator. So basically I'm doing 3.86 divided by 2. So that is going to be 1.93. Our moles of potassium cancel out, leaving us with moles of H2. So 1.93 moles of hydrogen. Okay. Let's try a second one. All right, how many moles of aluminum will react with 0.512 moles of hydrochloric acid? Again, we need to balance. All right. So let's see. I'm going to, and I'm gonna not go through how to balance this because we did that in the last unit. So to save time on the video. All right, so let's see. And do I have this right? Let's see. So 2 aluminum, 6 hydrogen, 3 times 2 is 6 hydrogen, 6 chlorine, 6 chlorine. Okay, so here's my balanced chemical equation. All right, so what do we know? We know that we have 0.512 moles of hydrochloric acid, and it tells us hydrochloric acid is HCl. All right, and then we're looking for how many moles of aluminum. All right, so you have to look in your equation when you're talking about moles of aluminum. It's going to be, so we want to put our ratio, our mole ratio, okay? So let's see, I'm looking for moles hydrochloric acid. So if I look in my equation, for every 6 moles of HCl, I would need to react 2 moles of aluminum. Okay, so let's set this up. 0.512 moles of HCl over 1. And now it's important to note, look at our units. So moles of HCl is going to go below. And then what we're looking for, moles of aluminum, is going to go on top. All right, and then I'm going to get my coefficients. So for every 6 moles of hydrochloric acid reacted, we would need 2 moles of aluminum. Okay, so now to do this math, I'm going to take 0.512 times 2, okay, over 1 times 6. So let's do this math. So 0.512 times 2 is 1.024 divided by 6. So I'm going to get an answer of 0.17, okay, moles of HCl cancel out, leaving me with moles of aluminum. Okay. So that's how you calculate moles of one thing to moles of another thing. Because when we go into the lab, this is what we want to be able to do. We want to be able to say, okay, I put 0.5, and we're going to have to weigh it in grams. I put 0.5 grams of substance A together with 2 grams of substance B. What, how much can I produce? Okay, that's the kind of thing we're going to be looking for. Another question that we can ask you is we could ask you to just to determine the mole ratios. Okay, so for example, in 1A, it says, what is the mole ratio of aluminum oxide, Al2O3, to Al? So what you're going to do is you're going to look up here, Al2O3, the coefficient is 2. Al, the coefficient is 4. So our mole ratio is just 2 to 4. All right, what is the mole ratio of aluminum to oxygen? All right, so we're going to look, aluminum is 4, oxygen is 3. All right, what is the mole ratio of aluminum oxide to oxygen? So aluminum oxide is 2, oxygen is 3. Okay, so that's how you are going to, we can ask you multiple things. We can ask you just simply, what is the mole ratio? And we can ask you, if we give you a certain number of moles, can we figure out how many moles of another substance we would need? All right, so that is a quick lesson on mole ratios. And I hope this was helpful. Have a great day, and I will see you in class.